Okay, today we're going to be looking at section 5.5, day 1 of standard form. Hopefully by the end of this lesson you can say I can graph a linear equation in standard form using intercepts. So here's the first problem we're going to take a look at. It says an athlete wants to make a snack mix of peanuts and cashews that will contain a certain amount of protein. Cashews have 4 grams of protein per ounce. Peanuts have 7 grams of protein per ounce. How many grams of protein will the athlete's mix contain? So for that, we could simply take a look at one of the points here. For instance, this point right here. It says there's 7 ounces of cashews and no peanuts. So 7 ounces of cashews, and I know that each one of those cashews got 4 grams of protein in it. So that's 28 grams of protein that they're looking to get. Okay, you can do the same thing up here with this point. That's 4 grams of, or 4 ounces of peanuts, and I know that 4 ounces, each one of them has 7 grams of protein. So again, that's 28 grams of protein for the mix. So what do these points tell you? 7, 0, this point right here tells you simply that there are 7 ounces of cashews and there are no peanuts. Where the other one, 0, 4, tells you the other thing. It tells you 4 ounces of peanuts and no cashews. So if we take a look here, standard form is this. Standard form of a linear equation is ax plus by equals c, where a, b, and c are real numbers and a and b are not both 0. So all the listed examples would be in standard form. So we're going to do today, we're going to look at how you go about graphing things in standard form. So first thing, we want to take a look at some things to try and lead into this graphing idea. So I want you to find 4 points along the x-axis of this graph, or a graph. So for instance, you may have found this, a negative 7, 0, a negative 4, 0, a 3, 0, an 8, 0. All these points are along the x-axis. And what do you notice about these points? You should notice that all the y values are 0. Okay, so then if we looked at the points along the y-axis, if I look along the y-axis, I could maybe pick this point here, which would be a 0, 6. This point here would be a 0, 3. This point here would be a 0, negative 5. And maybe this one a 0, negative 9. And we could see that all the points there, the x value is a 0. So the question becomes then, how can I use that information to graph? So if I'm given the equation 3x minus 6y equals 12, and I wanted to find an x-intercept. Well, an x-intercept is any point along the x-axis. So these values here are x-intercepts. So for an x-intercept, we have just found that the y value is a 0. So how can I use that? Well, I can plug a 0 back into my equation. So 3x minus 6 times the 0 equals 12. The 6 is gone, so it's just 3x equals 12. And if you divide by a 3, you would get x is equal to a 4, which means the ordered pair would then be 4, 0 for the x-intercept. So 4, 0. For the y-intercept, we found that the x's are 0. So if I put in a 0 for the x, I would have 3 times the 0 minus 6y equals 12. So this would be gone, so I get a negative 6y equals a 12. If you divide by the negative 6, you get y is equal to a negative 2, so your ordered pair would be a 0, negative 2. So I get the point 0, negative 2, therefore my line would be something like this. Okay, so let's try that one more time. So again, we're going to find an x-intercept. And for an x-intercept, I know y is equal to 0. So I'd have a negative 2x plus 4 times the 0 equals 16. So this would be gone. So you have a negative 2x equals 16. If you divide by the negative 2, you end up with x is equal to a negative 8. So your ordered pair would be a negative 8, 0. So negative 8, 0. Okay? For a y-intercept, I'd have negative 2x plus 4y equals 16. So for an a y-intercept, you let x equals 0. So if x were equal to 0, now this would be gone. So I'd have 4y equals 16 and divide by the 4, and y would be equal to a 4. So I'd have this point here, therefore your line would look like such. Okay, I'll show you one other little method here quick, and that would be the cover-up method. Cover-up method goes like this. If I want to find an x-intercept, I cover the y's. So I literally think of that as being gone. So I'd have a negative x equals 4, which means an x is equal to a negative 4, which means I've got the point negative 4 on my x-axis. Okay, for the y-intercept, you cover the x. So I'm covering up this, and you now have 4y equals 4, and if you divide by the 4, you know that y is equal to a 1. Okay, so the y value is 1, so I end up with this line here. Okay, the last thing that we have to cover is simply how do you graph if it's just x equals something or y equals something. So for that, we simply go back to a cheat chart. If x is equal to 4, you know the y or x value has to be 4. The y can be whatever. So we'd have 4, 1, 4, 0, 4, 2. So I'd have this line here. This is x equals 4. Okay, if I wanted to graph this next one, x equals negative 3, same idea. We have negative 3, so 0, a few different points, so a negative 3, 1. So these 3 points, this would be x equals negative 3. So hopefully we can see that any x equals is going to be a vertical line. So then if I change this one to a y equals 6, now we just have to put a 6 in for the y, and these could be whatever we want. So now I've got these points. So this is now y equals 6. Or if I gave you the equation y equals a negative 7, hopefully we could see that I'd have a negative 7 in here. The x could be whatever. And I'd end up with this. So hopefully we can see that any y equals equation is just going to be a horizontal line. So that is all I have. Hopefully we can understand the graphing part. If not, come with questions. And that is a wrap.